Hello everyone, welcome all viewers. My name is FAAS-Ahmed. In this tutorial, I'm going to show you something new. Is very important when you connect or create a network. Our discussion today about IP addressing. We will find out what is the IP addressing and what is the scheme or the structure of the IP addressing, the format of the IP addressing, and show the importance of the IP addressing. Okay? It's very important tutorial. Let's keep focus on this tutorial step by step. Okay? Are you ready? Let's go! So, IP address or Internet Protocol. This is an agreement, or it has a coordination of any network which enables the devices on a network can be communicated successfully depending on another protocol called ICMP. So, what is the IP address as definition? IP address is a logical IP address. Logical IP address. This IP address, we have two types of IP addressing. As you see, we have IP version 4 and IP version 6. Okay? And also, the IP version 4, it has set of subtitles such as private IP and public IP. So, all these known as IP addressing, which one can be distributed on LAN network, or one is for public network, or one network known as internet. So, let's see what is the IP addressing. For example, remember that when we created peer-to-peer topology, there is two types of IP addressing. Move to the IP configuration. See, this is the desktop of PC1, for example. Here we have this first tab, IP configuration, DHCP and static. This is for IP version 4. And the second tab, as you see here, this is IP version 6. Okay? This is the IP addresses that you should distribute it for each PC to identify this PC on a network. Okay? Great. Let's see what next. Now we need to take a look at the differentiation between IP version 4 and IP version 6. It's simple. This is the table as you shown here. IP version 4, depending on the size, it's shorter than IP version 6. IP version 4 has 32 bits or 4 bytes using binary system. When we say binary system, that means using port depending on 0 or 1s. This is create the IP version 4. IP version 4 as a whole, depending on binary system. Okay? As you see, this is an example. This is as a subnet mask, or the default subnet mask represent as a binary system to show you this is the binary system for using IP version 4, how to represent it to the system, how to work. Okay? And let's see IP version 6. IP version 6 as a size is larger than IP version 4. This should be considered with the differentiation of this IP addressing. The length is 128 bits or 16 bytes. This kind of IP version 6 using hexadecimal. When we say hexadecimal, this means started from 0 to 9 until from A to F. This give us hexadecimal. As you see, for example, these types of IP version 6 as represented when the system works with it. Okay? This is the simple differentiation or simple versus between IP version 4 and IP version 6. Is this clear? Okay, let's go. Now we need to take a look about IP version 4. IP version 4 has an IP addresses which says the length is 32 bits or 4 bytes. It has classification classified from set of levels or set of category. We have class A. This is the format of class A. N.H.H.H. This means we have 1 octet or 1/8 bits represent a network from the left side, and the 3 octet or the 24 bits represent the host. Okay, the red color for this letter, as you see, this represents the network, and the others represent the host. The default subnet mask for class A is 255.0.0.0/8. 8 means this is 8 bits as the default subnet mask for class A. As you see, the private IP 10.0.0.0. When we say private IP, this means the IP address is that as a network administrator, you should distribute it over a LAN network, not over a public network. Public network that use the public IP addresses by itself. This is distributed by using the DHCP. When connected your LAN network with the internet, automatically the routers or the servers that we connected give you an IP addresses as a public IP address. Okay, this is about class A. Let's move to class B. Class B, it has 2 octet or 2 or 16 bit from the left represent as the network version or network octet. This is the network octet, and the other for host or devices. As you see, the subnet mask is 255.255.0.0/16. That means what we have 2 version or 16 bit represent as a network and 16 for host version. Completely give you 32 bits. This is the length of class IP version 4. The private IP, this is for example 172.16, and the public IP as you see here. And let's move to the class C. Class C, we have 3 octet from the left represent as the network. This is called class C. That means we have 24 bits as the network version or network octet and 1 for host. The subnet masking as the default 255.255.255.0/24. Okay, the private IP, for example, 192.168.1.0. This is represented as a private IP address, and the public IP address as shown here, as you can see. So, and now we have another 2 categories, class D and class E. This is for special cases. Using class D, for example, for multicasting. This is we will figure out when we come to see what is the routing protocol. Okay, and class C for research and development. So briefly, we can say that the IP version 4 can be classified for classes into sub of categories starting from class A to C. This is available to distribute it over a network depending on private or public. Okay, while class D and E, this is for special cases. So that is for IP version 4 classification. Okay, let's summarize this. To conclude this tutorial, we can say that IP version 4 or IP addressing, as a definition, briefly, it is a unique number that should be assigned to each PC when connected to a network, a LAN network or a public network. Why? Because to give you an identity. Without it, there is no connection on a network. So this is one of the most important things you should consider about the IP addressing. Okay, great. Also, we mentioned that the IP address includes two important things. One, network version, and two, for host version. When we say network version, this is for network ID or for networking. And the host version, this is for endpoint when connected with the internet. Okay? This means when we match it or when the source sent a packet to specific destination, the subnet mask is responsible to match these IP addresses of the destination to find out is this the destination in the same network or not. If it's the same, the message will send successfully. Otherwise, we'll drop it instead of anything. Might be in another network, or this IP address is not in the specific or in the current network. So, I think this briefly about the IP addressing. For more details, you can visit the link as shown here in this slide and find out more information about the IP addressing. So, I think that is all for today, guys. Thank you and see you